Welcome to NCERT classes. Okay, in this video we will learn the chapter 3 of class 12, that is matrices. And matrices is a very simple concept and very useful applications are there which we will learn anyway. And in NCERT book, actually class 12th book, matrices is broken down into two chapters. Chapter 3 contains the basics of matrices and chapter 4 contains the determinants actually and applications of determinants. Okay, so we will do both the chapters one by one. In this video we'll cover only the chapter 3 and its fundamental understanding of matrices, usage of it, and then all the exercises which are given in the chapter 3. Okay, so let's get into this.
Struggling with Maths Olympiad or Engineering entrance prep? Let's make it simple. Welcome to Fun with Mathematics, your YouTube hub for mastering IOQM, JEE, and BitSat with clarity and confidence. For Olympiad aspirants, we dive deep into number theory, geometry, polynomials, recursive functions, and more, with daily practice problems and complete solutions to previous year IOQM papers. And if you're gearing up for JEE or BitSat, we've got you covered, with full NCERT classes for 11 and 12, solved exercises, and past year questions across topics like trigonometry, complex numbers, calculus, probability, and statistics. Every concept is broken down with tricks, trades, and visual clarity, so you don't just memorize, you understand. Whether it's sets and relations or the binomial theorem, we simplify the toughest topics and help you build real problem-solving power. Subscribe now at youtube.com/PSK99999 and let's make math your strength.
Matrices are very powerful mathematical tools used to simplify complex solutions. So this is where all the history of matrices started actually, to simplify the complex solutions, okay, calculations. Matrices has come. It is very useful in many areas of sciences actually, and especially when you want to do this rotation, reflection, magnification, all this, then matrices is a very good tool to use. Okay, there are several uses which you will know anyway once you start using it. Okay, now definition is matrix is the ordered rectangular array of numbers or functions enclosed in brackets. Okay, the individual values are called elements or entries, and matrices are denoted by capital letters like ABC. Okay, so example, matrices will have some rows and columns. Okay, I'll show you example anyway. And what is the order of matrix is? Matrix is, if the matrix has m rows and n columns, then its order is m by n, m cross n. We write it like this. Okay, and the total number of elements in that matrix are m into n. Okay, number of rows into number of columns. Okay, so example is, let's say if a matrices can be written something like this. Okay, a square bracket we will use, and in this matrix we have element e1, e2, e3, e4, e5, e6. Okay, 6 elements. And how do you get it? There are two rows. Okay, row 1 is e1, e2, e3. Row 2 is e4, e5, e6. If you look at the columns, we have three columns: e1, e4, e2, e5, and e3, e6. Three columns and two rows. So order is 2 by 3. Always write the row first. Okay, number of rows first when you write the order, then columns, number of columns, 2 into 3, and number of elements are 2 into 3 again, which is 6. Okay, so this is how you write the matrix and the basic understanding of the matrix notation. Okay. Okay, types of matrices. You can have several types of matrices. Okay, if you see, you can have a column matrix, which means it will have only one column, something like this, A, B, C. Only one column is there, right? And three rows. And you may have row matrix where you have one row but multiple columns. Okay, something like this, A, B, C. And square matrix where the number of rows equal to number of columns. Okay, so that is this is a 3 by 3 matrix, correct? It's a 3 by 3, 3 rows, 3 columns. So A, B, C, D, E, F, and G, H, I. Okay, and then diagonal matrix. Diagonal matrix are normally square matrix where the diagonal elements are non-zeros and other than diagonal elements are zeros. Okay, and a matrix will have only one diagonal which is major, or there is nothing major or minor, there is only one diagonal. Okay, this is the diagonal. Okay, where if you represent this by index a, I, j. Okay, I, j, I equal to j, then this is called diagonal. Okay, now identity matrix. It's a diagonal matrix where the diagonal elements are ones and rest are zeros. Okay, and a scalar matrix where it's a identity matrix multiplied with some scalar value. Okay, so something like a 0 0 0 a 0 and 0 0 a. Okay, So these are the several types of matrix which you can actually see. Okay. And yeah, let's understand more about this. Zero matrix you can have where all elements are zeros. Okay, something like this. Okay, equality matrix is if two matrices are A and B are equal, if and only if they have same order. Okay, order of those two matrices is matrix is same, and their corresponding elements are also equal. Okay, let's say you have something like this: 1 to ax is a matrix which is equal to 1 to ax. Okay, all the this is 2 by 2, this is 2 by 2, order is same, 1 equal to 1, elements corresponding elements are same, 2 to a and x x. Okay, so we use this relation to find out the variable values. Suppose 1 to ax is equal to bc34. Okay, then the variables ax and bc are the variables which we can say that b is equal to 1 because these two matrices are equal. C is equal to 2, a is equal to 3, x is equal to 4. Okay, so this is where you can use your variables and then find out the values of variable elements. Okay, let's get to, these are the basic stuff about the matrices, very basic. Let's do some exercise to practice these simple concepts right now. Okay, in the matrix A, okay, given here, write first the order of the matrix. Okay, order of the matrix is, if you see here, there is 1, 2, 3. Okay, there are 3 rows and 4 columns. Correct. So when I write here 4 by 3, you think it is 4 by 3. This is wrong actually. The order is actually 3 by 4. 3 rows and 4 columns. Okay. So 3 by 4 is correct. Okay. This is wrong. Next. Number of elements, yeah, you can either do 4 by 3 or 3 by 4, doesn't matter. Number of columns into number of rows basically. Okay, which is 12. Okay, then write the elements of A13, that is row 1 and column 3. This means, okay, this means row 1 and column 3. Row 1 and column 3, this is 19. Okay, A21, so second row, first column 35. A33, third row, third column minus 5. A24, second row, fourth column 12. A23, okay, second row, third column, which is 5 by 2. Okay, hope you understand how to use the indexes for the elements. Okay, next, if a matrix has 24 elements, what is the possible orders it can have? Okay, what if it has 13? So 24 is, we know that it's a composite number, right? It has several factors. So all factors are possible, right? And you have only rows and columns. So 24 elements can be written in a form where A into B equal to 24. Correct. So we have several ordered order of matrix possible. Okay, which is 1 into 24, 2 into 12, 3 into 8, 4 into 6, 6 into 4, 8 into 3, 12 into 2, and 24 into 1. Okay, 4 into 6 and 6 into 4 are not same. If you see, okay, this is 4 rows, 6 columns. This is 6 rows, 4 columns. Okay, are not same. So these many number of orders are possible. Okay, now what if it has 13 elements? 13 is a prime number. So prime number, definitely we know that it cannot have many factors, only one and itself. So it has only 13 into 1 or 1 into 13. Two types of matrices are possible, right? Uh, this is a column matrix and this is a row matrix, right? Next. Matrix has 18 elements. What are the possible orders it can have? What if it has 5 elements? Same as above. One is composite number, other one is a prime number. So you can do it yourself. Next. Construct a 2 by 2 matrix A equal to the index form they are given Aij, whose elements are given by some relation, right? Aij is nothing but I plus j whole square by 2. Now, how to do this? Now, we know that we are constructing a 2 by 2 matrix. So, what are the index possible? 1, 1, 1, 2, 2, 1, 2, 2. Correct? So, first is A1, 1. Means I is 1, j is 1. So, 1 plus 1 whole square by 2, which is uh, 2 square by 2, which is 2. A12, 1 plus 2 whole square by 2, which is 9 by 2. Okay. And A21 is 2 plus 1 whole square by 2, which is 9 by 2 again. A22 is 2 plus 2 whole square by 2, which is 8. So, sorry, this should be 8. Okay. This is not 2. This is 8. So, because 4 square is 16, 16 by 2 is 8. So, this is 8, A22. So, this is how you construct a matrix where the index is given with some relation between the indexes. Okay. Element indexes. So similarly, you can do other problems. Okay. Okay. Okay, now here it is 3 by 4 matrix. Nothing different, only the order is different. So number of elements you will get differently. You will get 12 elements here. Okay, so each row you will get 3 elements, which is A11, A11, A12, and you apply this relation here. Okay, suppose example A11 if I take minus 3 into 1, which is minus 3 plus 1, which is minus 2. This is in modulus, so that is 2. 2 by 2, which is 1. Okay, so similarly you will do a12, a13, okay, a14. Okay, so this somehow I made a mistake. This is twice I wrote a14. Okay, so similarly other rows also you will do it, and you will get the matrix here. Okay, you can cross check your answers. Okay, next, construct a 3 by 4 matrix where the index is given. Same way as previous one you will do it. You just cross check your answers. Okay, find the values of x, y, and z from the following equations. Okay, this is simple. 4, 3, xy, 4, 3, xy is equal to yz 1, 5. So we know that x is equal to 1, correct? Y is equal to 4, z equal to 3. Corresponding elements you have to equate. That's all. Simple. Okay, and here it is x plus y equal to 6, xy equal to 8, 5 plus z equal to 5, correct? So you start with where you have less number of variables, that is here, right? 5 plus z equal to 5, which means z is equal to 0, so you got 0, and you have two equations for x and y, which you can solve it directly by substituting, correct? X is equal to 8 by y, so you substitute here 8 by y plus y equal to 6, or y square minus 6y plus 8 equal to 0, you will get a quadratic equation. Solve it, you get y is equal to 2 or 4. Okay, and which means x will also will have two values. X is either 4 or 2. Okay, so this is how you will take the help of equality of the matrices. Okay, similar, you have three variables and three equations, so you can solve it yourself. Okay, yeah, find the values of ABC from the following equations. Same, you have multiple equations given. You take the equations where same variables are used. Something like a minus b equal to minus 1, 2a minus b equal to 0. Correct? From these two equations, I can, if I solve these two equations, I'll get a value and b value, which is 1 and minus 2. Okay. Similarly, other two equations will take 2a plus c equal to 5, and I already have a value, so which means c value is 3. Okay, and 3c plus d equal to 13, and I have my c value, I have my that's it, c value is there, so I'll substitute it, I'll get d value, which is 4. Okay, so this is how you solve these equations from the matrices elements. Okay, a equal to aij, it's a m cross n, is a square matrix if, okay, so it will be a square matrix only if m equal to n, we know it, right? So that's the answer. And which of the given values of x and y make the following pair of matrices equal? Okay, so options are given. It's a simple problem. 3x plus 7 equal to 0. So x equal to minus 7 by 3. Is it there? X equal to minus 7 by 3 is not there anywhere. Okay, then y you take y minus 2 equal to 5. So y is equal to 7. So y equal to 7 is there in two places. Okay, but the corresponding x value is wrong. Correct? And cross check, you might get multiple values for x. Okay, so it is not possible, right? If you get multiple values for x, you cannot have a equality in this matrices, correct? So the answer is not possible to find the x and y values. Okay, next, the number of all possible matrices of order 3 by 3 with each entry 0 or 1. Okay, so this is a good problem. It's more of permutations and combinations actually. A 3 by 3 ordered matrix, how many elements are there? 3 into 3, which is 9. 9 elements. Each element can be either 0 or 1. So how many options are there? Okay, each element has two options. Okay, now how many total possibilities are there? There are 9 elements. So 2 into 2 into 2 up to 9 times, which is 2 to the power of 9. That is 512. Correct? So that's what the answer is. Option for each element is 2. Okay, total possible combinations of matrices are 2 to the power of 9. Options are possible using the 0 and 1 for each element. Okay, which is 2 to the power of 9. So 512. That's the answer. Option D is correct. Yeah, now let's learn the operations on matrices. Okay, now we know that matrices individually we have done, but let's do some multiplication, addition, subtraction. Let's see if division also possible in matrices. All those things we will learn now. Okay, operations on matrices. Addition of matrices. Two matrices can be added if they are of same order. Okay, so the definition is very simple. You add the corresponding elements from each matrix and then form the new matrix. That's all. So example, let's have some factory production data of factory A, which is 80, 60, 75, 65, 90, 85, which is a 3 into 2 matrix. Okay. Factory B also a 3 into 2 matrix. Only then you can add. You cannot add matrix of different orders. Okay. So factory A plus factory B, that combined production is A plus B, which is nothing but 80 plus 90, 60 plus 50, 110, 75 plus 70, 65 plus 55, and so on. Only add the corresponding elements. Okay, so this is how the matrix addition can be done. Okay, now next is scalar multiplication of matrix. Okay, so if k is a scalar, okay, and k into a, that is k times the matrix is nothing but k times each element. Okay, k times each element. Suppose 2 into matrix, the given matrix here, then it is nothing but, yeah, 160 double basically. 80 has become 160, 60 has become 120, 75 has become 150, and so on. Okay, and negation, of course, if you are multiplying with -1, every element will become -1. Okay, then difference is a minus b is nothing but a plus minus b, means you are basically first doing minus b and then adding it to a. Okay, same definition. This is a scalar multiplication of matrices. Next. Yeah, and the properties of these addition and scalar multiplication is, yeah, addition is commutative. A plus b is equal to b plus a. It is also associative. A plus b plus c equal to a plus b plus c. Okay. Additive identity, does it exist? Yes, it exists. A null matrix or zero matrix is basically a additive identity. A plus 0 is equal to 0 plus a, which is also equal to a. Additive inverse, of course, minus a also exists. So a plus minus a is 0. So minus a is additive inverse. Okay. These are the properties of matrix addition. Then these are the properties of scalar multiplications, which is k times a plus b is equal to ka plus kb. K plus L times A is equal to Ka plus La. Then K times L times A is equal to KL times A. Okay. These are the properties of scalar multiplication. Now let's understand the matrix multiplication. Okay. Condition is columns of, suppose if you want to do multiplication of matrix A into matrix B, then columns for A should be equal to rows of B. Okay, this is the very important condition to remember. Only then multiplication is possible. Otherwise, multiplication is not possible. Okay, you can go through the definition here, but how it can be done is, let's say matrix A is 1, 2, 3, 4, 5, 6, which is a 3 into 2 matrix where there are two columns here, correct? And matrix B has two rows. Okay, this is what should be equal. Okay, two columns of A should be equal to two rows of B. Then 1 into 2, you multiply with this column. Okay, 1a plus 2d you will do addition. So you will get one element here. Second element is 1, 2. Okay, it's a dot product basically. If you consider this as a vector, 1 comma 2 as a vector, b comma e as a vector, this is the dot product of these two, correct? Which is 1 into b plus 2 into e. Okay, then 1 into c plus 2 into f. Then similarly, you take second row again, multiply again the each column. Okay, 3a plus 4d, 3b plus 4e, and 3c plus 4f, and third row into each column again. Okay, so you will get basically 3 into 3. Okay, 3 into 3 elements, and this matrix order is 3 into 3. This is how you will do the matrix multiplication. Again, condition is there where columns of A should be equal to rows of B. Only then matrix multiplication is possible. Okay. Now properties are, is it commutative? No, definitely it is not, because uh, if you take A into B, if it is possible, and B into A may not be even possible. Okay, the number of rows may not be equal to number of columns there, right? So it is not guaranteed that AB is equal to BA. Okay, so it is not possible. It is not commutative. Associative, yes, AB into C equal to A into BC, identity, there exists a identity matrix. Okay, sorry, I did not put in square brackets. Okay, identity matrix of 2 by 2 is nothing but, suppose 2 by 2 matrix is 1 0 0 1, where you have the diagonal, all the diagonal elements are 1 and rest of them are 0, then it's called identity matrix. This is for uh, 2 by 2. And one more thing you should note down is, even though I say that identity exists in matrix, okay, it does not exist for all the orders. Okay, it is only for identity matrix exists only for the square matrices. Okay, distributive, yes, a times b plus c is equal to ab plus ac. Okay, or other way, this one, a plus b times c equal to ac plus bc. Okay, and just note down, zero product is possible even if neither matrix is zero. Okay, so these are the multiplication properties of matrices, and this is about the matrix multiplication. So let's get into the exercise. You will understand more with the practice. Okay, how to do all this. Okay, A, B, C are given. Find each of the following. One is A plus B. So both are same order. So you can do addition. Corresponding elements you can add. So I am writing it explicitly. 2 plus 1, 4 plus 3, 3 minus 2, and 2 plus 5, which is 3, 7, 1, 7. Okay. Similarly, you can do for A minus B. You just sign will change basically. Instead of A plus B, it is A minus B. And 3A minus T, first you will do 3 times A, which is 3 times 2, then plus 3 times 2, the C element is minus 2, so minus C is minus of minus 2, which is plus 2. Okay, carefully you do it. It is simply just like any other numeric addition or subtraction. Okay, just you will do it for each element. That's all. That's the only difference. Okay, so you can do it yourself. And the multiplication of AB, yeah, of course, A has two columns and B has two rows, so we can do multiplication. So 2, 4, dot product with 1 comma minus 2, which is here. 2, 4, dot product with 3 comma 5 is here, and second row, first column, second row, second column. Okay, so this is the answer. Okay, then BA also calculate. Now you can see, actually we just now said that AB is not equal to BA, right? So AB is minus 6, 26, minus 1, 19. BA is 11, 10, 11, 2. So which are not equal. So matrix multiplication is not commutative, not symmetric. Okay, next. Compute the following, which is straightforward. Okay, you add the corresponding elements, you will get the answer. Okay, all are same basically. Then you can apply any number theory simplification. Suppose here it is a square plus b square plus 2ab, which is nothing but a plus b whole square. B square plus c square plus 2bc, which is b plus c whole square. A square plus c square minus 2ac, which is a minus c whole square. A square plus b square minus 2ab, which is a minus b whole square. Okay, simplification can be done for each element like this. Okay, so this is another 3 by 3 matrix addition. Straightforward, you can do it yourself. Okay, this is a trigonometric, each element is a trigonometric function and you can do addition. Okay, so cos square x plus sin square x, which we know it is 1. Sin square x plus cos square x also 1. Sin square x plus cos square x 1. Cos square x plus sin square x, which is also 1. Okay. Okay, this is just a product, so you can do it yourself and cross check the answer. This is straightforward. Okay, row into column, first element, row into second column, second element, second row into first column, third element, second row into second column, fourth element. Okay, do it carefully. Okay, can it be done first? One column, one row. Yeah, it can be done. So the answer is, each column you'll multiply with, sorry, each row here, 1 into 2, 1 into 3, 1 into 4. So this is a 3 into 1 matrix. This is the 1 into 3 matrix. So resultant will be 3 into 3. The outer side orders of the two matrix, you will get the resultant matrix. So you will get a 3 by 3 matrix. Do it carefully. Similar. Yeah, another 3 into 3 matrix. So you will get 3 into 3 output. Okay, this is a 3 into 2 and 2 into 3. So you will get a 3 into 3 matrix. So see the difference. Okay, one important thing you should note down is, here it is this matrix also multiplication, you got 3 by 3 result. This matrix is also, the result is a 3 by 3. Okay, so be careful about these outcomes. Understand this matrix multiplication is not straightforward like addition or subtractions. Okay, next. This is also similar. You have a 2 into 3 matrix multiplied by 3 into 2. So you will get 2 into 2 answer, correct? Okay. Here three matrices A, B, C are given. Then you compute A plus B, B, C, and also verify uh, A plus B minus C equal to A plus B minus C. Okay. So this is a simple. Already they said what to do. So this is A plus B. We know it. This is B minus C. Sorry, I made a mistake here. This is B minus C. Okay. And A plus B minus C. Okay. This is my A plus B minus C. Okay. This is my A plus B minus C. Are they same both? That's important. Yeah, both are same. Correct. So we can verify it. We can say that A plus B minus C equal to A plus B minus C is verified. Okay. This is another kind of a simple problem which you can get is A and B are given. Compute 3A minus 5B. Because orders are same, I can do scalar multiplication first and then subtract them. Correct. This is the answer. Now you get a null matrix 3 by 3 order. Okay. Simplify this one. First is cos theta, you will multiply with each element here. Sin theta, you will multiply with each element here and then add. Okay. So what you will get is cos square theta sin theta minus cos theta sin theta cos square theta. Here sin square theta sin theta cos theta minus sin theta cos theta sin square theta. So if you add them basically wherever cos square theta plus sin square theta is there, you will get 1. And this one is, we know that this is a sin 2 theta formula. Okay, minus sin 2 theta formula here. That's it. Okay, next. Find x plus y, x and y if x plus y and x minus y of the matrix are given. Okay, so this is almost similar to how you solve the equations. Okay, so if I add these two equations, I'll get 2x equal to sum of these two matrices, correct? Which is nothing but 10, 0, 2, 8. Okay, now this is 2x. So my x is 1 by 2 times this matrices. So each element I am multiplying with 1 by 2, which is 5, 0, 1, 4. Okay, this is my x. So this is how you will solve equations of matrices. Okay, and once you know x, y is nothing but this sum minus y is sum minus x is y. Okay, so that's what I'm doing it here. This is how I'll solve it. Okay, similar one, 2x plus 3y is given, 3x plus 2y is given. You find x and y. Same we'll do with how you solve the equations. Okay, when two equations are given, how do you solve it? Same similar way you'll do it. Okay, solve it yourself and then cross check the answer. Okay, these are very simple. I'm not going into details. Okay, another one, y is given, 2x plus y is given, find x. Okay, so y you replace first and take it to the other side, you'll get negative, correct? Minus y. Okay, 2x x equal to half times this sum of this matrices minus y, correct? So just substitute, you will get the answer. This is another way, almost similar. Only thing is here you are finding the variable values of this x and y elements. Okay, so this first you do 2 times, then add this one, correct? Then this is equal to 5618. Okay, so which means 2 plus y equal to 5, which means y equal to 3, and 2x plus 2 equal to 8, which means x equal to 3. Okay, and this is also similar to the above. 2 times variable matrix plus 3 times a matrix equal to 3 times some other matrix. First to do scalar multiplication, then equate, and then equate the corresponding elements to get the equations. Okay, once you get the equations, 2x plus 3 equal to 9, x is 3, 2z minus 3 equal to 15, z is 9. Okay, then 2y equal to 12, so y is 6, 2t plus x is 18, so t is equal to 6. This is how you'll solve the individual variables. Okay, next. Yeah, another problem again similar. X times matrix plus y times matrix equal to sum of the matrix is given. Find x and y, which is exactly same way. You'll get two equations. Okay, 2x minus y equal to 10, 3x plus y equal to 5. You solve it. Okay. Actually, from 11th question, you need to do one observation, important observation here. Okay. At this point, okay, at this point, I know what I am doing here, right? I am doing E1 plus A2 gives us this one. So if I add them basically E1 plus E2, this row to the above row, if I add it, Okay. Similarly, this 5 I added to above element, which is 10, 15. Then you can solve it here itself. Correct? You can solve it here itself. So, which means all the equation operations, whatever you do, you can do on rows and columns of matrix also. Okay, so remember this one. This is very important, which you will use later in the higher matrix operations. Okay, so in a equal matrix, if you are changing rows and columns, the matrix remains same basically. Okay, the information in the matrix remains same. Okay, so you can do operations on rows and columns uh, on both sides of the matrices. Okay, next. This is another matrix variable problem, which is simple. You can do it yourself. Scalar multiplication equal to sum of two matrices. Do it, then equate the corresponding elements and then get the values. Okay, next. Okay, f of x is given, and then f of x into f of y equal to, we have to show this. Okay, this is very simple. Already it is show that. So you just take first is f of x we already given. F of y is nothing but cos y minus sin y is 0, sin y cos y 0, 0, 0, 1. Okay, now f of x plus y is cos of x plus y minus sin of x plus y 0, sin of x plus y cos of x plus y 0, 0, 0, 1. Now I need to do multiplication of these first two matrices, correct? So multiply them. What I will get is exactly same as f of x plus y. Okay, so we can prove, we can say that f of x into f of y equal to f of x plus y for this matrix. Okay, so don't think that in matrices this formula is always correct. No, for this matrix it is correct. Okay, then similar, these two are not equal. Very simple, I think. It's a matrix multiplication. We know AB is not equal to BA, so you can just try the values. If both are equal, you are just lucky. Okay, it does not mean that they are equal. Okay, so this is one multiplication, this is other one, both are not equal. So same, exactly similar, different bigger matrix they gave. Okay, so both are not equal. AB is not equal to BA. Okay, now here find a square minus 5a plus 6i equal value if a is given. So first you need to find a square, which is a into a. Okay, so a square is a into a, and this is the value of matrix a into a, that is a square. Then minus 5a or 5a, 5a is 5 times each element. So this is my 5a. 6i is 6 times each element in I. So this is my 6i. Now I just need to do the a square minus 5a plus 6i. Correct? So this is the operations for each element, corresponding element. I will do minus and plus. Then I get the answer. Okay. Simple, straightforward question. Okay. Next. Similar, exactly similar. Okay. You find first a square, then multiply with a, you get a cube. Correct? And you need to keep all the values a square, a, and a cube. So this is a square, this is a cube, this is 7a and 2i, and then I need to add a cube minus 6a square plus 7a and plus 2i, which is nothing but null matrix actually. Okay, all zeros I got. A and I are given. Find k also, k, so that a square equal to ka minus 2i. Okay, so this is simple. Already they have given what we should find out. First is a square, which is 1 minus 2, 4 minus 1 if I multiply, matrix multiplication. Then I need to find k such that ka minus 2i equal to 0. So ka is nothing but this value 3k minus 2 minus 2k 4k minus 2k minus 2. Okay. Now 3k minus 2i is this value. Okay. So now I have to equate. These two are equal, right? So if I equate common terms, only thing is whenever you do such problems, you don't take one equation and say that this is the value. You cross check with other variables also. You should get same value. Only then k has a fixed value. Otherwise, if from this equation 3k minus 2 equal to 1, you got some k value, and minus 2k equal to minus 2, you got a different value of k, then you cannot really say that k, which one is k. Correct? So you have to make sure that all four equations will give a consistent k value. That is important. Okay. So 3k minus 2 equal to 1, and all these values are written here. K equal to 1 satisfies all four equations, hence k equal to 1. This is a very, very important point to note down. Just don't try only one equation and then say this is the k value. It has to satisfy other equations of k, okay, or variable. Next. Yeah, this is another problem which they said show that, okay, which means you know how to form it, right? A and I are given A plus I. This is my A plus I plus A. This is my I minus A. Okay. Now I minus A into this matrix cos alpha minus sin alpha cos alpha, which is here. Okay. Multiplying, this is what I got. Okay. Now I'm just doing simplification of this one. Okay. I got cos alpha plus sin alpha tan alpha. So tan alpha I can write it as sin alpha by 2 by cos alpha by 2. That's what I wrote, and take LCM. So this is what simplification of each one I did same thing exactly. Expand tan alpha by 2, then took the LCM and then wrote it here. Okay. Now simplified it. Okay. If you are good in trigonometry, you can easily understand what I am writing here. Okay. Each element is simplified here. Simplified element is written here, which is nothing but, okay, which is nothing but, so this is if I take one element here, cos alpha minus alpha by 2 is nothing but cos alpha by 2. So this cos alpha by 2 by cos alpha by 2, which is 1. This is sin alpha by 2 minus sin alpha by 2 by cos alpha by 2, which is tan alpha by 2. Okay. Similarly, all values. This is same as I plus A. I plus A is here. Okay. So we can always tell this given expression is valid. Okay. Next. Okay. A trust fund has 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year, and second one pays 7%. Use matrix multiplication to and determine how to divide 30,000 among two types of bonds. Okay, this is normally we solve using equations. Okay, and we'll do same thing with the matrix, basically almost similar. First, the total amount 30,000, let it be x, and 30,000 minus x. So x amount you will invest in first bond, 30,000 minus x you will invest in other bond. Okay, so your amount matrix is this one, x comma 30,000 minus x. Correct. Now your interest matrix is 5 by 100, 5% and 7%. Okay, this is your interest matrix. Now multiplying this one, you get interest, right? Okay, so if I multiply, I get interest. So the total interest is this value here, which is either 1800 or 2000. So I will equate this to either 1800 first one, then I get x value as 15,000. Okay, and if I equate it to 2000, I get x value as 5,000, which means, okay, x value I'm getting, right? So that means I divide the first investment into 15,000 and 15,000, I get 1800 interest. If I divide this into 5,000 and 25,000, I get the interest 2,000. Okay, so this is how we do. Okay, next. This is also very similar to the previous one. Okay, first you need read the question carefully. Okay, 10 dozen, 8 dozen, and 10 dozen books. Okay, which means 10 into 12, 8 into 12, and 10 into 12. So my books matrix is 120, 96, and 120. My price matrix is 80, 60, and 40. If I multiply, I get total price, which is 20,160. Okay, next. Assume that X, Y, Z, and W and P are matrices of order 2 into N, 3 into K, 2 into P, N into 3, and P into K, respectively. The restriction on Nk and P so that Py plus Wy will be defined. Okay, which means you should be able to do multiplication of P and Y and multiplication of W and Y, and then you should be able to add Py matrix with Wy matrix. Okay, so we know the conditions for multiplication and addition. So we should use those conditions to define what should be the condition for this N, K, P, and K. Okay, so let's see. Matrix orders of Py plus Wy will be, okay. So P is nothing but, if you see P is here, which is P into K, okay, and Y is 3 into K, plus Wy is N into 3 into 3 into K. So we know that this multiplication is possible because it is 3 into 3 and the resultant will be N into K. It's possible. But here K has to be 3 for this multiplication to be to exist, correct? This multiplication can exist only if K equal to 3, correct? And then the result will be, so K should be equal to 3 and result will be P into K. Okay, and here it is N into K. So N and P should be equal, only then the addition is possible. So these are the conditions we have to use to find out the values of these orders. Okay, so k equal to 3 is 1 because this multiplication should exist. And then if k equal to 3, this same expression I am rewriting it in this form, which is p into 3 plus n into 3. So addition is possible only if n and p are equal, correct? So n equal to p is another condition which should be possible. Okay. So these are the two conditions which should be satisfied for this py plus wy should to exist, to be defined. Okay. Okay. This next problem also similar to the above. Okay. If n equal to p, which is already given, then order of the matrix is defined or not defined, basically. Okay. So 7x minus z, 5z is nothing but 2 into n minus 2 into p. So this subtraction is possible only if n equal to p, and n equal to p is already given. Correct? So which means the resultant matrix order is 2 into n. Okay. And the 7x minus 5z will exist. Okay. Next. Yeah, that's all about this multiplication or addition. Okay, now next let's understand the transpose of matrices. Okay, transpose is defined as uh, a matrix where the transpose of a matrix of the original matrix is nothing but interchanging the rows and columns. This is the most important thing to understand. You will make all the rows into columns and columns into rows. Okay. If you take a square matrix, you will not understand the transpose easily. So easy way to understand is take a rectangular matrix. Okay. The definition is here. You can go through that. But example, you see the example. Take a rectangle matrix A, B, C, D, E, F. Okay, and transpose of a matrix is represented by either a dash or a to the power of t. Okay, transpose t for which is nothing but a d. Okay, a d is column here, it has become row. B is second column, it has become second row. CF is third column, it has become third row. Okay, so this is the transpose of matrix. Okay, this is one very important property of matrices which is used for solving several science problems actually. You will know when you find the applications of matrices. Okay, but this is the important concept. And some properties of the transpose of matrices are given here below. AB whole to the power of whole transpose basically. Okay, AB whole transpose is nothing but B transpose into A transpose. Okay, this is up to this. I just didn't give space actually. Okay. AB whole transpose is equal to B transpose into A transpose. Ka whole transpose means K is the constant here, K times A. So it will become, you can take K out also, K A transpose. Okay, up to this. This is second property. Third property is A plus B whole transpose equal to A plus B whole transpose equal to A transpose plus B transpose. This is third property. Okay. And then A transpose whole transpose is, you will get the original matrix back, which is A. Okay. I think there should be, yeah, enter or somehow it got all jangled into one actually, one line. So these are the four properties of matrices which are important of transpose of matrices. Okay. Next. Symmetric and skew symmetric matrix. This is another property of transpose actually. Symmetric matrix is nothing but if a square matrix A is symmetric, okay, and it is only for square matrix, only if A transpose is equal to A, which means if you take example, if A is 1 3 3 1, okay, 1 3 3 1, then A transpose also same, correct, which means this is symmetric matrix. Okay, note that only square matrices can be symmetric. Okay, now skew symmetric matrix. What is skew symmetric matrix? When A transpose is equal to minus A or A equal to minus A transpose. This is the example here. You will understand very easily. Correct? And note that in skew symmetric matrix, diagonal elements of they have to be 0. Only then it is possible. Correct? If it is any other number, then minus value will change that value. So 0 minus 0 is 0. That's why it is possible here. So two conditions. One is symmetric or skew symmetric can be applied only for square matrix. One. Okay. And for a symmetric matrix, diagonal elements should be same. Okay. Only square matrix and diagonal element should be all same. Then for a skew symmetric matrix, the diagonal element should be 0. Not only just same, they should be 0. Okay. So these are the conditions. And if you take any matrix A, you can express in terms of symmetric, sum of symmetric and skew symmetric matrix. Okay. So that is something like half into A plus A dash plus half into A minus A dash. If I expand it, okay, half A plus half A, which is 1A, half A dash minus half A dash gets cancelled. So this is equal to A, correct? And important point to note is A plus A dash is a symmetric matrix. Okay, if you want to convert a matrix into its skew into its symmetric matrix, you should do A plus A dash. And A minus A dash is a skew symmetric matrix. Okay, so now I am expressing A in terms of sum of symmetric matrix and skew symmetric matrix. This is the important point here. Okay. Next, yeah, let's do some exercise on this transpose of matrix. Okay, transpose of each of it. I'll not go through all, but you can do it yourself. One or two I'll explain. So here it is a column matrix. It has become a row matrix, correct? Transpose. First element, first element in the column, first element in the row, correct? Second element in the column, second element in the row, same as third. Okay. So this is how you'll do. So do it carefully. Transpose of matrix. Don't get confused. Write one by one. Either you do it row wise or column wise, but you do same way. Okay. If you are mixing rows and columns and then doing, then you may go wrong. Okay. This is the other one. You can do it yourself. And this is to verify a plus b whole dash equal to a dash plus b dash. Okay. So this is simple. We know how to do a plus b. Correct. Then we know how to do a plus b whole dash. Fine. Then what is a dash and b dash? We know how to do the transpose of matrix. Then sum of a dash plus b dash is the resultant matrix. Now you cross check. Okay, a plus b whole dash, this matrix, a dash plus b dash is this matrix. Both are same, which means a plus b whole dash equal to a dash plus b dash. We verified that. Right? Next. Same, a minus b whole dash equal to a dash minus b dash. Same way you can do it. Okay, you can verify it. Next. A dash and b are given, then verify that a plus b whole dash equal to same thing, but a dash is given, not a. Okay, careful. So a plus b will become a plus b. Okay, this is a dash. So if I take a will become 3 minus 1 0 4 2 1. Correct. It will become a this columns, two columns will become two rows here. Correct. Plus b. Okay, so this is the a plus b, then a plus b whole dash, then a dash plus b dash. This matrix both are same. So a plus b whole dash equal to a dash plus b dash. Okay. Same thing. We'll again verify a minus b whole dash equal to a dash minus b dash. Similar way. Next. Again, same thing. A dash is given, b is given. Find a plus 2b whole dash, which is nothing but you can do whatever you want. You can do a plus 2b. Okay. Because this is a dash, you first write the a, which is transpose of a dash. Correct. Then 2b, then a plus 2b. That's it. Then whole dash, a plus 2b whole dash. Next. Verify that ab whole dash equal to b dash a dash where, okay, we have to just verify. So a is given, b is given. Find out one by one. First ab, a dash is this one, correct? B dash is this one. Now ab is this matrix is 3 by 3. ab whole dash is transpose of ab, which is here. Okay. Now b dash into a dash is again b dash into a dash is again same thing you will get. Okay. You do it yourself, you'll get same value. Okay. ab whole dash equal to b dash a dash. Okay. Next. Same way you will do the other problems also. Do it carefully. 3 by 3 matrix, you will have so many multiplications and additions. So do them carefully. Okay. This is other one. A dash whole dash a dash a equal to I. We have to verify, and a is given. So you can do it yourself. This is a dash. A into a dash is nothing but this value. Okay. Which is 1001 you will get. So which means I. Okay. Same thing. Similarly, you can do it this one also. Next. Show that this matrix is a symmetric matrix. How do you show? Find out A transpose and cross check with A. It should be equal. Correct? This is A. This is A transpose, which is same as A, which means it is symmetric. Okay. Show that this is a skew symmetric. How do you do? Same way. A is given. A transpose is this value, which is nothing but exactly minus of A. Okay. If you apply minus to every element of A, you will get A transpose. Correct? So that means it's a skew symmetric matrix. Okay, then matrix A, which is 1, 5, 6, 7, verify that A plus A dash is symmetric and A minus A dash is skew symmetric. We already know this formula, the principle. So we just verify it. Okay, A plus A transpose or A dash. Okay, this is my A transpose or A dash. Add both of them, I get 2, 14, 2, 11, 11, 14. Okay, now transpose of this one is nothing but 2, 11, 11, 14. You will get same again. Correct? So which means it is nothing but A plus A dash. Okay, now A plus A dash is a symmetric matrix. Okay, now A minus A transpose. Okay, which is nothing but 0, minus 1, 1, 0. Okay, which means A minus A dash whole dash equal to 0, 1, minus 1, 0. Okay, you get exactly by applying minus to A plus A dash, A minus A dash, sorry. Okay, so this is a skew symmetric matrix. Okay, you can easily see the elements, right? Minus sign is changed from this one to this one. So if you apply minus on this one, zeros will remain same, but this will become plus one, this will become minus one. That's all. Okay, and this is minus. Okay, sorry, not plus. This is minus. Next, again, this is what we want to find out. A as a sum of symmetric and skew symmetric matrices. So just is doing step by step. So first is A transpose, which is minus A already. Okay, since A equal to minus A dash equal to minus A, right? So half of A plus A dash is nothing but null matrix we'll get, and half of null matrix is a symmetric matrix, right? Okay, symmetric, and half of A minus A dash is nothing but uh, that is A dash is nothing but A, so minus A, so it will become A plus A half by 2, which is A. That is same as this one. This is already a skew symmetric matrix. If you see, given matrix is already a skew symmetric matrix. So this is same. Next. Okay, A is given. You should express in terms of half into A plus A transpose plus half into A minus A transpose. That's it. Okay. So first A plus A transpose half into A plus A transpose is 3 minus 1, 3, 3, 3 minus 1. Half into A minus A transpose, which is equal to 0, 2 minus 2, 0. Okay. Now I can verify that the sum of these two is equal to the original matrix, which is 3, 5, 1 minus 1. Correct? So this is, I expressed A in terms of symmetric and skew symmetric matrix, two matrices. Okay. This is exactly same as above. We'll do same way. Same, exactly same. 4 and 3. Okay, both are the same. You have to make half into A plus A dash, half into A minus A dash, and verify that sum of these two is equal to the original matrix A. That's it. If AP are symmetric matrices of same order, then AB minus BA is. Okay, options are given. Find out, you take A and B. Some simple example. Okay, so let A be 1, 2, 2, 4, and transpose of A is nothing but again same 1, 2, 2, 4. So it is symmetric matrix. Similarly, B is ABBC. Transpose of B is also ABBC, so it's symmetric. Correct? You take the example matrices in such a way that the operations don't result in different values or same values. Okay, so here in this case, even if I do multiplication, you actually cannot find out the evaluate this value, because one is ABC and other one is 1 to 4, right? So that's how you should take. Now AB is nothing but this value, BA is also, I'm getting actually same value, correct? Because they are symmetric. So AB minus BA is a null matrix, so option C is correct. Okay, now A is given, A plus A dash equal to I, then what is the value of alpha? Okay, so simple. This is my A, this is my A dash, all the trigonometric elements are there. Okay, now my A plus A dash is nothing but 2 cos alpha 0, 0, 2 cos alpha, which is equal to 1, 0, 0, 1, which is by equating the matrices, I should equate the elements. So 2 cos alpha equal to 1 or cos alpha equal to half, right? So alpha general answer is 2 and pi plus or minus pi by 3. But if you take only first quadrant, answer is alpha is pi by 3. One answer if you want to take, then alpha is pi by 3, you can take it. Okay, next. Yeah, let's understand the inverse of the matrices. Okay, This is mathematical inverse of the matrices. Okay, does it exist? Yes, it exists, but under given conditions. Okay, what are the conditions? We'll understand and how to do this. Okay, first is definition. If AB equal to BA, which is equal to IM, okay, then we can call each one inverse of the other matrix. Okay, if AB equal to BA equal to identity matrix, only then we call it A is the inverse of B, and it is denoted by A to the power of minus 1, A to the power of minus 1. Okay, what is the condition? Both should be square matrices, first thing. Okay, so that means only square matrices are invertible. Then matrix and inverse are of same order, of course, because they are square matrix. Okay, for a 2 by 2 square matrix A, B, C, D, the inverse exists only if AD minus BC equal to 0. Okay, AD minus BC is called the determinant of matrix. You will understand more of these determinants in the next chapter, which is chapter 4 in the class 12 NCERT. Okay, and the formula for inversion for 2 by 2 I am giving here. 3 by 3 you will learn in the determinants anyway. Okay, if it is A is matrix A is A, B, C, D, then inverse, which is A to the power of minus 1, is nothing but 1 by AD minus BC. D and A will change its positions. Okay, B and C will get its negative negation. Okay, so D minus B minus C A. Okay, multiply with the scalar AD minus BC. So, okay, when I said AD minus BC should exist, this is because it is in the denominator. If this is equal to 0, then there is no value of 1 by 0, right? So inverse does not exist in that such cases. Okay, so this is the simple definition of inverse of matrices. More you will learn in the determinant section. Actually, these problems here, very simple problems are there, one or two, which you can do it. This is a straightforward question. If and only if AB equal to BA, that's correct. Okay, but not complete. AB equal to BA equal to 0, that is wrong. AB is 0, BA is I, no. AB equal to BA equal to I, that is complete definition of inverse of matrix. Okay, next. Find the inverse of matrix 1, minus 1, 2, 3. Okay, so simple. First thing is determinant D equal to AD minus BC. So 1 into 3 minus of minus 1 into 2, which is 5. So my inversion matrix inverse is nothing but 1 by 5 into 3 and 1 and 3 I will change position. So 3 and 1 minus 1 and 2 I will negate them. So 1 and minus 2. Okay, now if I simplify, this is nothing but 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5. Okay, since we are doing first time, you cross check actually whether you get I or not. Okay, so multiply A and A inverse, you will get 1001. Okay, next. Find the inverse of the matrix. Same way you will do, exactly same way. A determinant is 1, A inverse is nothing but 1, minus 1, minus 1, 2. Okay. Yeah, next let's do some miscellaneous exercises, which is the last in this chapter. Okay. A and B are symmetric matrices. Prove that AB minus BA is a skew symmetric matrix. Simple. You take A is a symmetric, so A equal to A transpose, B equal to B transpose. Correct? AB minus BA is AB minus BA transpose is nothing but transpose, you can carry it inside. So AB transpose minus BA transpose, which is, if I expand it more, this is B transpose into A transpose minus A transpose into B transpose. Correct? Since A equal to A transpose, B equal to B transpose, I can call it BA minus AB. Okay, BA minus AB is nothing but minus of AB minus BA. Correct? So this is skew symmetric. Correct? AB minus BA transpose is equal to minus of AB minus BA, which is skew symmetric. That means this is a skew symmetric matrix. Okay, next. Show that the matrix B dash AB is symmetric or skew symmetric according to A is symmetric or skew symmetric. Okay, so that means first let's say A is a symmetric matrix. Let's assume. Okay, which means A equal to A dash. Correct? Now B dash AB whole dash is equal to, I will take it as these two matrix as one. So AB whole dash into B dash whole dash. B dash whole dash is nothing but B, we know. And this AB whole dash is nothing but B dash into A dash. Correct? Now A dash is nothing but A. So I'll replace it back. B dash AB. So where we started? We started with the transpose of B dash AB and we got it B dash AB only. Which means this is symmetric. B dash AB is symmetric because A is symmetric. Okay, case 1. Now let's say A is skew symmetric. A is skew symmetric, which means A equal to minus A dash. Correct? Now again start same thing. B dash AB whole dash, which is nothing but AB whole dash into B dash whole dash, which is nothing but B dash A dash into B. Okay, A dash is nothing but minus A, so I'll put minus A. So I am ended with minus B dash AB. Okay, which is nothing but exactly skew symmetric definition of B dash AB, correct? And we started with the assumption that A is skew symmetric. So the symmetricity of B dash AB depends absolutely on A. If A is symmetric, B dash AB is symmetric. If A is skew symmetric, B dash AB is skew symmetric. Right? This is what we want to prove. Okay. Find XYZ if the matrix A is given, satisfy the equation A dash A equal to I. Okay, this is simple. Find A dash A, correct? A dash A, which is nothing but 100, 100, 010, 001, which is I. So if this is equal, then you equate the variables, right? Elements, corresponding elements, you equate 2x square equal to 1, 6y square equal to 1, 3z square equal to 1. So we will get values of x, y, and z, which is either plus or minus 1 by 2, plus or minus 1 by 6, and plus or minus 1 by root 3. Sorry, not 1 by 2, plus or minus 1 by square root of 2. Y is plus or minus of 1 by square root of 6. Z is plus or minus 1 by square root of 3. Okay. For what values of x? 1 to 1 into, okay, this matrix into this matrix equal to 0. So just do step by step. Okay. First to do the ones without variables. Okay. Leave it. Okay. So this one you will get 6 to 4. Then into this third matrix, which is 4 plus 4x, which is equal to 0, which means x is equal to minus 1. Okay. Simple. A is given. We have to just show that a square minus 5a plus 7a equal to 0. We have done similar problem in the other exercises, so you can do it yourself. Okay. Find x if multiplication of these three matrices is 0. Just we have done fourth problem same way actually. Okay, you can do here only difference is here variable is there in two matrices. So you can do whatever way you want. You first to take the two matrices, multiply. Then third one multiply. You get one single variable because you will get one by one matrix in the end. Okay, this is equal to 0, right? So which means x square minus 48 equal to 0 or x is equal to plus or minus 4 square root of 3. Next. Okay, a manufacturer produces three products XYZ, which he sells in the two markets. Okay, market one and market two. In market one, he sells these three products XYZ in the number 10,000, 2,000, 18,000, and in market two, he sells 6,000, 20,000, and 8,000. Find the total revenue in each market with the help of matrix algebra. Okay, if uh, unit sale prices of XYZ are 2.5, 1.5, and 1 respectively. Okay. Then if unit cost of the above commodities is this is cost, this is sale price. Okay. So we can definitely find gross profit easily. Correct. So this is my sale matrix of the products in two markets. Okay. Market 1, market 2, 10,000, 2,000, 18,000, 6,000, 20,000, 8,000. My selling price is coming from here, which is nothing but 2.5, 1.5, and 1.0. Okay. And my cost matrix is coming from here, which is 2, 1, and 0.5. Okay. Now, simple. What is my revenue? Revenue is product into selling price, which is P into S. So, nothing but 46,000 from market 1, 53,000 from market 2 revenue. Okay. Now, gross profit is nothing but revenue minus total cost. So, PS we already have minus PC. PC is here. Okay. Products into cost matrix. Okay. If I simplify this, I get 15,000 and 75,000. This is my profits from market 1, market 2. Gross profit is sum of these two, right? Which is 32,000. Okay. This is my gross profit. So this is how you take help of matrices to solve such problems. Okay, this is you can solve it without matrices, but when the information is very big, several market goes to hundreds of markets, product goes to tens of products, then matrices is a better way of solving the problem. Okay, find the matrix X so that X into matrix equal to this given matrix. So simple. First thing is find out what should be the order of X. That is important. Okay. So this is a 2 by 3 matrix and I am getting a 2 by 3 matrix in the result. Okay, so this should be 2 by 2. That's the only option, correct? Because if it is columns are not 2, then I cannot multiply and in the result I'm getting two rows, so these rows should be 2. So 2 by 2 matrix. Once you know this, you don't need actually to do the matrix inverse method. You Since it is a 2 by 2 matrix, it is simple. Okay, let x be ABCD. So ABCD into 1, 2, 3, 4, 5, 6 equal to minus 7, minus 8, minus 9, 2, 4, 6. Now I multiply them. Okay, A plus 4B equal to minus 7, correct? And 2A plus 5B equal to minus 8. From these two equations are enough for me to derive, solve the variables A and B, correct? So A and B are minus 2, minus 2 and 1. Okay, B is minus 2, A is 1. Similarly, CD also I get two equations, and from those two equations I can solve D equal to 0 and C equal to 2. So my X, that is A, B, C, D, are nothing but 2, 1, minus 2, 2 and 0. Okay, this is how you will solve the problems. Next. A is given alpha, beta, gamma minus alpha such that A square equal to I. Okay. So A into A I will do first. So I am getting alpha square plus beta gamma 0, 0, beta gamma plus alpha square, which is equal to 1, 0, 0, 1. If I equate the corresponding elements, alpha square plus beta gamma equal to 0. Correct? Equal to 1, sorry. Or 1 minus alpha square minus beta gamma is 0. That is the option. Sorry, this is not A, this is D, but option C is correct. Okay, option C is correct. Correct option. Next. If matrix A is symmetric and skew symmetric, then okay, it is symmetric and skew symmetric. Okay, it is, if it is symmetric, A equal to A dash, skew symmetric, A equal to minus A dash, which means A has to be null matrix, only then it is possible. Correct? Right? So that's the answer. If A is a square matrix such that A square equal to A, then I plus A whole cube minus 7A is equal to. Okay, so this is simple. A square equal to A, which is given. So 1 plus I plus A whole cube minus 7A, you expand it first, which is nothing but I cube plus 3I square A plus 3I A square plus A cube minus 7A. Now I square is nothing but I, correct? So I, then I into A is A, 3A plus 3A plus A cube, I am writing it as A into A square minus 7A. Now A square is again I am writing it as A. Okay, this is 6A minus 7A, which is minus A. Okay, so I minus A plus A into A, which is equal to I into minus A square is again A, correct, which is given. So A, so which is I. So I'm getting the answer I. Option C is correct. Okay, yeah. That's all the miscellaneous exercises. Let's note down few important points actually. One is, if A and B are square matrices of the same order such that AB equal to BA, then we can also say A b to the power of n equal to b to the power of n A also. This is also correct. Similarly, you can put power to the A also. Correct? I just kept it for one matrices, but you can put it A to the power of M, A to the power of M here. Okay. This is important one which will be helpful for several problems. Okay. Now A and B are symmetric matrices of same order, then AB is symmetric if and only if AB equal to BA. Okay. Now inverse of matrix A dash will exist and it is unique. If it exists, it is unique. That is another point. For any square matrix A plus A dash is symmetric, A minus A dash is skew symmetric. Okay. A square matrix can be expressed as a sum of symmetric and skew symmetric matrices in this form. Okay, which we learnt already. So these are the important points to note in the matrices, which are useful in several places later. Okay. Yeah, that's all. This is a simple topic. Actually, matrices, very basics are there. You go to determinants and then try to solve all the matrices related problems for the engineering entrance exams. Okay. So keep doing maths till then. I'll come up with next chapter, which is determinants. Okay. Thank you.